So if you know that you are taking this upcoming Jamb examination and Waec, oh yeah, make una gather here, right? The chemistry, physics, maths, English, well loaded from GMAT 41, no time. I have got this question here that a student sent across, and I would like us to solve it, okay? After this, I still have another one that was sent across, and that one is on electrolysis or so. But we're going to deal with this one first. Like I said, if you know you are taking this upcoming examination, don't waste time. GMAT 41 is going to be carrying you through gradually and steadily, okay? No time to waste. Let's go straight to deal with this question I have here. It's a Jamb question. It's also a question that Waec can ask. Any exam body can ask this question. To what temperature must a gas at 273 Kelvin be heated in order to double both its volume and pressure? Lest I forget, I also want to communicate to our Waec students and of course those in 100 level in various schools. Remember that under gas law, you can also be asked this question. So I want to follow through as I deal with this question on the board. It's a 1+1 problem actually. Okay? Now, to what temperature must a gas at this temperature be heated? The gas is at this temperature initially. So I can say that T1 is equal to 273 Kelvin. Now, to what temperature are you going to heat that gas? You don't know. But under this condition, it is expected that when you heat it to this temperature, the volume and the pressure, both of them will be doubled. Okay? Now, we don't know the final temperature. The initial pressure, let's represent it with P1. The initial volume, let's represent it with V1. Now coming to the final condition when you heat this gas to a certain temperature which we don't know, the T2. At that time, it is expected that the final pressure will be doubled, meaning twice the initial pressure. Also, the final volume is going to be twice the initial volume. So these are the data provided in the question. And once you get this, the problem is solved. If you look at this information we have on the board, we have temperature, we have pressure, we have volume. Boyle's law, Charles' law, and Avogadro's law, these three laws combined have been used to generate an equation called the general gas equation on the gas law in chemistry and or in physics, because we also deal with gas laws in physics. So we're going to use the formula P1 V1 divided by T1 equal to P2 V2 divided by T2. And we shall substitute the values here. P1, we are going to maintain it as P1, the initial pressure. The initial volume will maintain it. Then the initial temperature, if you look at the question, is 273. So we're going to fix 273 here. That's going to be equal to final pressure. So this is going to be 2P1. And also, the final volume is twice the initial volume, V1. We're going to divide it by the final temperature, which we do not know. And that's it. Solve and make the final temperature T2 subject of the formula. But observe something here. You have P1, V1 on the left-hand side. All these things you have here is multiplication. You have P1, you also have V1 here. This is also multiplication, you know that. So you can decide to divide both the left-hand side and the right-hand side by P1, V1. Take note of that. Don't go punishing yourself, trying to make T2 subject to the formula with P1, V1, P1, V1 still left in this substitution being done. We can divide through by P1, V1. If I divide it by P1, V1, I'll be left with 1. Then divided by P1, divided by V1 also. You see, we'll be left with 2 times 2, which is 4. Cross multiply, T2 times 1 will give us that final temperature that we are expecting to get. All right, and then 273 times 2 times 2, that is times 4. What is it going to give to us? 4 times 3 is going to be 12, right? To carry 1. 4 times 7 is 28, plus the 1 is going to give you 29. Write 9, carry 2. 4 times 2 is going to be 8, plus the 2 you carried, you get 10. Therefore, this temperature to which the gas was heated so that the volume and pressure will be doubled, that temperature is 1092 Kelvin. I hope you enjoyed and understood the calculation here, right? Like I said, from this question is just for you to understand the grammar that is spoken there. You are given the initial temperature of a gas. They're asking you to what temperature must you heat that gas. So you don't know what the final temperature is going to be. But once you heat that gas to that temperature you are looking for, it is expected that both the volume and the pressure will be doubled. Which means if you have initial volume and initial pressure, the final volume and final pressure is going to be 2 times their initial values. Then apply your general gas equation, which you have here, and you have your answer there. If you're yet to subscribe to this channel, right away hit the subscription bell. Turn on the notification bell also, so that once I upload any content, you will be personally notified by YouTube, okay? And also remember that you can become a channel member, where you get access to video lessons exclusively for our channel members. To become a channel member and join our learning community, click on the Join tab just below this lesson. You'll see the GMAT 41's packages. Please select from the platinum level and above. Support GMAT 41 and become a channel member so that we'll continue to give you the best. On this channel, the GMAT 41 has provided the lessons on all the gas laws: Boyle's law, Charles' law, Graham's law. You want to learn more about them and get further information about the gas laws, then you have the end screens showing here, okay? You can click on them and it's going to take you straight to the video lessons on gas laws. I'll be seeing you in my next video. Share this video to all the friends, please, okay?